Okay, let's see. Number 5 has our difference of squares again. And it looks to me like once more we're going to want to use the 1 minus, oops, I'm getting it backwards. Works both ways, but 1 minus sine squared theta equals cosine squared theta. So I am going to replace my y with a 5 sine theta. And again, we get this whole thing where at first it seems like we're making more mass, but then things simplify nicely. So dy is going to be a 5 cosine theta d theta, which is going to turn this into a 5 sine theta over 25 minus 25 sine squared theta. And then we have a 5 cosine theta d theta. Okay. So my scratch work here is I factor up my 25. Again, I don't need to see this. This is just for you. If you don't need it, don't do it. That's fine. 1 minus sine squared is the same as cosine squared theta. So this is going to turn into the integral of, hold on, what do we have? So on the top we still have our 5 sine theta. On the bottom we now have a 25 cosine squared theta. And then we're multiplying by 5 cosine theta d theta. Okay, so the 25 cancels with the 2 5s. We get to get rid of one of our cosines. And we're left with, what are we left with? Sine theta over cosine theta d theta. Okay, and this is in fact a tangent theta, but if we want to integrate, I actually think I like it better as is. So I'm going to say that w now could replace the cosine theta. So we got it simplified. We no longer have the difference of squares floating around. Here with the sine and the cosine involved, it's just becoming a basic w substitution, which means that the dw is a minus sine theta d theta. I think we got into this exact same w substitution earlier. So here, let's see, I'm going to move the minus sign over to the other side and say that sine theta d theta gets replaced by a minus dw, and cosine theta gets replaced by a w. So now we want the antiderivative, so a minus floating right out in front, but otherwise the antiderivative of 1 over w, which is natural log absolute value of w plus c. And then we can replace the w's with cosine theta, but we're still not done. We need to go all the way back to our y. So we can say that if y is equal to 5 sine theta, then solving for sine theta gives y over 5. So when we draw a triangle, we can say that y is opposite and 5 is hypotenuse, which means that the bottom has to be square root of 25 minus y squared. Again, that's always just that Pythagorean theorem, a squared plus b squared equals c squared. Okay, so replacing cosine theta using the triangle, we get, what do we get? Adjacent over hypotenuse, so we have a square root of 25 minus y squared over 5. And you can rewrite that, no need to do it here, but you can absolutely use log properties, so if you don't remember them, you might look back at them, they can be handy. We can split this into, the minus sign will have to distribute out in front, but the log splits into the natural log of the square root of 25 minus y squared minus the natural log of 5, and then you can write that square root as a 1/2 power. So there are things you can do, no need to do them here, but they're certainly legal. Alright, thanks for watching.